Excellent. Hello and welcome, folks. We're just going to give everybody a minute to funnel in here, and we'll get started in about 60 seconds. We'll get started in just another minute or so. Just letting folks funnel in. All right, and there we go. Well, welcome everybody, and thanks for joining us today for our webinar on the future of AI and LP. AI is out there just about everywhere right now, and some people know what it is, some people don't, and we're really interested to hear what it's going to do for our industry and what we could look forward to, what we could not look forward to, and maybe get a little advice from a legal perspective as well on some of the privacy concerns and some of the other side of things. We've got a great lineup for you here today. As usual, my partner in organized retail crime, Jack Britton, is here. Jack, how are you?
Hey, Kevin. Hey, everyone. Good to see you today.
Yeah, thank you very much, everybody, for joining us today. We appreciate you being here, and let's get started. So, as we usually do when we first start, we can't do these types of webinars and this education sessions without these wonderful solution provider partners. We've got Hanwha Vision, Sensormatic, Salient Systems, Appriss Retail, Dragon Fruit, and ThinkLP with us today. So very excited to have our sponsors with us, and please do take the time when you have a minute to go and check out their websites, learn a little bit more about them, go see them at the trade shows. Show them some love. Without them, we wouldn't be able to do these types of sessions, and we really appreciate them, and we hope that you do too. Let me tell you a little bit more about each one of them. So starting with Hanwha Vision, create safer and smarter retail environments for your employees and your shoppers. Hanwha Vision's intelligent retail surveillance solutions combine 24/7 protection with AI-powered data analysis capabilities, cloud management, and image quality. Configure the right surveillance infrastructure for your store to strengthen loss prevention, maximize customer traffic patterns, reduce checkout wait times, and increase your operational efficiency. Check them out today at hanwhavisionamerica.com. Next up, we have Sensormatic. Sensormatic is on the forefront of loss prevention innovation that also delivers great visibility into shrink and improves operational efficiency. Our innovative solutions are designed to help retailers protect their merchandise, prevent shrink, and fight the threats posed by retail crime, while still delivering frictionless experience for shoppers. Want to see these solutions in action and something brand new? Well, stop by their booth at NRF Protect coming up in June out in Long Beach, and they're going to be in booth 1142, or you can check them out at sensormatic.com. And next sponsor I'll tell you about. The other ones we're going to kind of spread out, but the next one I'll tell you about, I don't have to say a word about because they're going to do it for us. This is a little bit about ThinkLP.
Noticing an uptick in incidents of workplace violence? With California's Senate Bill 553 in play, it's time to act. By July 2024, your California team needs a solid prevention plan and training. ThinkLP is here for you. Now, you can easily capture and report incidents, automate alerts, and create action plans. Join the ranks of hundreds of retailers worldwide who trust ThinkLP.
Great. Well, thank you to those sponsors and to our education partner, the Loss Prevention Foundation. If you are LPQ or LPC certified, this webinar today does qualify you for 3 CEU credits. So please make sure that you keep track of that and add it to your profile. Next up, we want to just thank Loss Prevention Magazine and remind you that if you are not already subscribed to the magazine, that you should do so today because it is free, F-R-E-E, free. You can scan the QR code on the screen. If you're not quick enough to get your phone out to scan it right now, that's okay. I'm going to bring it back a little bit later before we go to the end. So have that phone ready, scan that QR code, and you can get subscribed to both the print magazine and to the online solutions and our online daily emails and thought leadership articles and all that great stuff. if you scan the QR code and get signed up today. For anybody on the phone that is tied into anything ORC related, or if we have any of our law enforcement partners on the phone today, we also want to make sure that you're aware of the scholarships that are available. If you are in retail and you have law enforcement partners, please make sure that they get a hold of me. I've got a ton of scholarships available to pass out to folks, so please make sure that they get a hold of me to pass out. If you are in law enforcement, reach out. We can get your whole department trained. And I think last but not least is just to remind everybody that the nominations for the LP Hall Awards are open. They've only got about a week to maybe 10 days left. So if you have not already made your nominations for the LP Team of the Year, for the Investigator of the Year, the Investigation of the Year, new this year, we have the Outstanding Orca of the Year. Please make sure that you get to lphall.com and get those nominations in before it's too late. All right, Jack, I think that's enough out of me.
Okay, great robots today, Kevin. Good job with those slides. They look terrific. Okay, first up, we have Amit Kumar, who is the founder and CEO of Dragonfruit AI. Amit, can you tell us a little bit about yourself before we get started?
Yes, absolutely. In fact, that was one of my first slides. So do you want me to just jump into my slides?
Absolutely, just go there. Just share your
All right.
screen and let's go.
Let's do it. Well, I'm really excited for the invitation. I'm happy to chat a little bit about what I think, what our company thinks in terms of future AI and LP. In my slides, in my presentation, 3 things I want to cover. First of all, why am I listening to this guy? Like, who the heck is this guy and where did he come from? Second, what's up with all this AI ML crap that everyone keeps talking about? And the third is, how will it change my day-to-day? So in the next 20, 25 minutes, I want to cover these 3 things. And just a quick thing about us, who we are and who I am specifically. I'm the founder and CEO of Dragonfruit. I've been doing this for a while. This is my 3rd company. And Dragonfruit itself is thinking about how to harness video data. And the idea is to process all of this video data locally using our Apple platform. We use Split AI to reduce the cost of bandwidth. So a lot of video processing can be done on the cloud, but typically retailers don't have enough bandwidth for it. And we want to provide a single solution or single product which solves for multiple LP problems. So monitoring, analysis, alarms, and compliance. And as I said, I started this company about 5 years ago. We're widely deployed around the world, particularly in retail, but also facilities and venues. But beyond that, I'm going to keep my intro short and really focus on number 2, what's up with AI and ML? Like, what the heck is going on, right? Suddenly it has broke through. I mean, I started a company, Dragonfruit AI, 5 years ago, but certainly in the last couple of years, people have been talking about AI more and more. So in this section, what I really want to talk about is what do you need to know, right? What is the basic, fundamental baseline that you need to know? What's the cheat sheet? So today, in this second section, I'm going to talk about these keywords, right? And I'm going to talk about these one by one, so you don't have to read through all of this. And the goal here is at the end of the next 10 minutes, you have a basic understanding of what the vendors mean when they talk about AI ML, what CNN and MSNBC mean when they talk about AI ML, and what your kids mean when they're talking about ChatGPT, right? So for those who have kids. Now, we have talked about video analytics. We have been hearing about video analytics for decades, really, right? The CCTV cameras have been around for about 50, 60 years now. And what's new this time? Every time there seems to be something new. So what's new this time? Well, traditional approach to understanding images and therefore video is really, how do you teach a computer? And let's say in this example, there's a person standing in a field. Where is the person? Is there a person? Where is there a person? And the traditional approach to this is to identify this by writing a lot of code. We all know programmers write code. So fine, write some code, and now you can identify a person. The MLAI approach is really to teach a computer to identify that person by showing it millions of examples of people. So instead of looking at pixel by pixel and saying, this looks like a hat, this looks like trousers, this is an arm, this must be a person, you're like, you know what? You deal with it. And you tell the computer, go figure it out. So for example, if you think about false alarm detection, right? If you are using a traditional approach where you're doing pixel by pixel understanding, you can probably figure out that the image on the left is a fox. But the image on the right, is that actually a critter climbing a fence, or is it actually a human being, right? It becomes extremely hard because maybe that is a face, maybe that is a pair of legs, right? You don't quite know. And turns out that with AI, this gets reduced down to about 90% from a false alarm detection perspective. And why is that? Excuse me. It's because computers are good at understanding stuff. If you teach them properly, they can actually figure a lot out. But how does that relate to ML, right? So let's talk about how ML works in practice. A few terminology notes first, right? So what's the difference between AI, ML, and computer vision? AI is basically, you have human intelligence, we're trying to simulate it. So anything that is trying to simulate human intelligence, we call AI, right? So it could be machine learning, which is really a subset of AI, where you are learning how to write programs. So computers are learning how to write programs. That's a subset of AI. There can be AI where, machines are not supposed to be learning anything. They're just, kind of close to human intelligence. But if you're teaching them, if they're learning, we call it machine learning. And if you're teaching them how to do computer vision, in other words, interpret images and videos, we call it computer vision. So AI, ML, CV. See, now you're smarter already, because now if someone says we are an ML company, oh, because they are teaching the system to learn something. If they say we are an AI company, you can ask, are you an ML company? Are you training systems to get better, or you're just an AI company? And are you a CV company, or you're not? So for example, if Press Retail, they are an AI company, they might be doing ML, but they're not a computer vision company because they focus on data, statistics, and analysis of point of sale data, etc. And Dragonfruit is a CV company because we deal with images. So now that's your AI, ML, computer vision. So what is models? What are ML models? What is this learning? What does this inference mean? Let's talk about that. I'm sure a lot of you have heard of the term GIGO, or remember it, garbage in, garbage out. That was, 10, 20, 30 years. I'm already dating myself. Yes, it is black hair, but I'm quite old. That's thanks to my dad. The whole concept of garbage in, garbage out was you get input into a computer, it gives you output. That's how we think about computers, right? So for example, you give it an input of an image, and you want an output of like a red box around the person. Well, the way you achieve this is by writing a program. And we've all seen this like code written on the right. I'll pretend that I don't write code myself. My programmers do, but I do. So this is the program that you give it to the computer. So the computer gets an input and a program and generates an output, which is, hey, I have this person I identify, right? With machine learning, what you do is interesting. You give it a bunch of inputs to the computer and say, hey, here's a bunch of pictures and some outputs like, hey, I've already drawn a rectangle around the person I want you to detect. So you take a bunch of inputs, you give it a bunch of outputs, which is labeled data, and tell the computer, create a program for me. Right? So it's almost backwards. So instead of input generating an output, what machine learning is a bunch of inputs and outputs generating a program. These outputs we call patterns. So you're giving some patterns to the computer, and the process of creating a program is called training. If there's any questions about this, of course, there's Q&A. I can answer later, and you can queue them up as well. But that's basically what's happening with machine learning. It's generating a program, and that program we call a model. So when a vendor says we have this amazing ML model, what they're saying is we took our computers and we gave it a bunch of input and output, and it generated a program for me, and we're going to call it an ML model and confuse the heck out of you. But really, it's creating a model, a program. So traditional programming is inputs and programs creating outputs. Machine learning is inputs and outputs creating a program. Now, we use certain terminology to, as I mentioned before, and the terminology is basically how do you connect all of these things together, right? How do you take a program created by machine learning, feed into a traditional programming model, because that's how every computer works, right? So we need to bring the AI universe and like the machine learning universe and the traditional programming universe together. And this is part of the terminology jargon that you keep hearing. We train using inputs and outputs. So that's training. We create an ML model. We feed this ML model to this system called the inference engine, which takes new inputs and creates new outputs. So the training has all kinds of inputs and outputs of all kinds of different images. But if you give enough of them, next time the computer sees something that is new and unique, they will be able to interpret it and create an output and give you the person detection that we were looking for. So that's machine learning. Training creates a model which you use during the inference time to generate whatever you're looking for. This is almost magical. In this image from one of our customers, there's smoke that is spreading. This is a fire and smoke test. And usually when I have more time, I let people guess where the smoke is. But this is where the smoke is. You can barely see it. And the reason that AI can figure this out is because we fed it literally thousands and thousands, probably like 1 million examples of smoke and fire. And so it learned how to detect it. And this is something that is extremely hard to do pixel by pixel. Like, where are the pixels? Where is the smoke? How did you code it? Traditionally, you can't. You have to use AI for this kind of thing. So now we know AI, ML, CV, ML models, learning and inference. Now, what do we mean by neural networks? What is deep learning? What are people talking about? The machine that is used doing inference, where you get an input and getting an output, that's what it looks like. You have an input, it runs through a series of steps, and you gets to output. The number of steps you have determines whether it's learning or it's deep learning. Seriously. Deep learning simply means it passed through multiple steps of analysis. That's it. You know, if someone says, "Oh, we are a deep learning company," you should say, "How many layers in your CNN?" And they'll be like, "Oh, I don't know. I have to ask my engineers." Well, if you don't know, why are you calling yourself a deep learning company, right? So the way to think about these layers is, when you go to the optometrist, they have a series of lenses, right? That they'll put one lens in front of another to figure out what, the focal length is that they require, or what have you. Similar to adding multiple lenses makes your vision get better, and then you get a final number, of course. That's how CNNs work. So in these layers, what's happening is when you get an input, let's say get an image, the first few layers are saying, "Oh, where are the edges? Where are the blobs that I can observe?" Then the next set of layers are saying, based on these edges and blobs, I can make out some textures. The next set of layers are saying, based on these textures, I think I can recognize like a clock there, or like some blobbish stuff is happening. And then finally, the set of layers are saying, actually, I understand it's the ship, because I see certain edges and blobs that I'm familiar with, certain texture that feels like it's a ship. In fact, I see a bunch of ship, like I see a sail. Therefore, I think I'm looking at a ship. This is what deep learning is. A bunch of layers of understanding, and each layer is giving you a little bit more knowledge about what it's looking at, and that gives it a sense of what the objects are that you're trying to infer, you're trying to understand. This is extremely helpful. For example, in this case, you're seeing an image, and again, if I had more time, we would let people guess, but there is a liquid spill here somewhere. And it's very hard to find out, except if you're a machine, you're like, this is where the spill is. And how does it know it's a spill? Is because it knows that typical spills in the world have a little bit of reflection at the edges, where it's like, where it's crusting over the surface. There's some reflectivity, it's an organic shape. All of this is how you're able to figure out that this is a liquid spill. Very, very hard to do without deep learning, very, very hard to do without machine learning, very, very hard to do without AI. So that's neural networks. Neural networks basically layers of network, layers of analysis also deep learning if there's a lot of layers. Now let's talk about object understanding. So we saw liquid spell, we saw some fire and smoke, right? These are objects. So the ML guys will say sometimes, or AI guys will say, oh, we understand 45 objects. What do they mean? Well, if they're not explaining it to you, first of all, you should object. But really what the objects are, like a spill is an object. It's not technically an object in the common parlance, right? But from AI perspective, these are all objects, right? And once you have an object, what you want to do, you want to detect it. So locating objects within images or videos is called detection. So can you detect if this particular image has a spill or has a fire and smoke? So the detection is a technical term. Can you track it? So if you have smoke, is the smoke moving, right? Does it start somewhere and it's moving? So if you're able to track it, you say it's tracking, it's object tracking. Then it's recognizing it. Is it, is it a fog or is it smoke? Those are the kind of things that you're trying to understand. That's recognition. You're recognizing, identifying, classifying objects based on categories. When you're talking about humans and sometimes animals as well, but most commonly humans, if you're trying to figure out where the limbs are, where the head is, that's pose estimation. So you're defining the pose. So for example, when we do shoplifting detection, we're using pose estimation and how the pose is changing. We're tracking the pose over time to see if it's shoplifting. And then finally, classification. So if we are detecting a vehicle, is it a red vehicle? What brand is it? What type is it? All of that goes into classification. So when people say, oh, we have amazing object understanding, we can detect, we can track, we can recognize, we can do pose estimation, we can do classification, this is what they mean. All right. So we know AI, ML, CV, we know ML models, we know learning, inference, we know deep learning, and now we understand what object understanding is, right? That brings us to like a year ago. And then suddenly we have ChatGPT. What the heck is going on with that now? So let's talk about generative AI. We've been talking about, in the first part of my presentation, you get a whole bunch of video data, right? And you give it to the machine, to the computer, using some computer vision model, CV. See, you know CV now. What if we took a whole bunch of text data, and instead of interpreting video, we are interpreting text? And let's say you have a lot of text, right? Large amount of text, and you're understanding language, right? And you want to do it through machine learning, right? So you would build a model, right? And you would build a language model because you understand language, and you wanted to understand large amounts of textual data. So the geniuses who name things in computer science call it a large language model. So that's where the LLM comes from. So it's a large model that understands language. So it's LLM. And I won't even explain what the GPT acronym stands for. There's no reason it should have escaped the CS labs. But it's basically an LLM. So what's generative about it? Well, if you think about the problem space that we were talking about, hey, here's an image. Is there a person in here? You pass it to a computer vision model, and then it says, yeah, I do have an image of a person. So that's a interpretation of an image. But what if we wanted something different? We said, look, I am giving you a first word for a sentence, right? Complete it, right? Like we know how autocomplete works in iPhone, right? Like you type in a word and suggest the next word, right? Just complete it for me. And that's really what the computer is doing, is it's giving you the next most plausible word. The first is interpretation of an image, of text, tell me what's going on. And the second is generation, where given a starting point, you're asking the computer to do more. So all of this ChatGPT stuff, surprisingly, that's all it's doing. You ask it a question, and it's like, flips a coin and says, what's the most likely first word of an answer? If you say, what's the capital of Egypt? Like it knows that the most likely first word in the response is the second word is capital of Egypt is, right? This is the most likely response to the question, what's the capital of Egypt? And then there's like, oh, now I gotta go figure out what the right answer is. Is it Cairo? Is it Alexandria? And then it figures out the most likely word and then answers the question. This is generation. So all ChatGPT, all of these are generative AI because they're generating text or videos and images, but generative AI versus interpretation. Why is this interesting? Well, let's say you have a wall of numbers, right? You have, we do at Dragonfruit, we do a bunch of analysis of like traffic and walk-bys and sales data. But what if you had literally a wall of numbers and you wanted to understand what the heck is going on? Max occupancy, departmental traffic. What we do is we pass it to ChatGPT, right, or some other LLM, and it basically summarizes this wall of data, right? So executive summary creation by interpretation of vast amounts of data is an example of how you would use generative AI. All right, AI, MLCS, model learning, inference, deep learning. You should be proud of yourself because you know more now than all of your friends, right? But even if you know all of this, how do you actually deploy this, right? And so that's where deployment challenges come in. If you're thinking about video AI, on-prem analytics, where you're taking all of the video and analyzing it, it's expensive. If you're doing it on the cloud, you don't have enough bandwidth. So that's a key deployment challenge for all of this video AI. And so there's new ways that people are trying to solve it. For example, split AI, where you take existing camera feeds, so you don't need AI on the camera, so you don't have to rip and replace. You do local analysis of that using video AI. And then you have this connected to the cloud. So you have these AI models. Now you know what AI models are, ML models working in tandem. And so you get the cloud scalability because you're connected to the cloud, but you get the low hardware cost because you're doing AI processing on-prem. And so you're not sending all of this data, so it's low bandwidth as well. So this is a crash course of AI terminology. Hopefully that made sense. In the next 5, maybe 7 minutes I have left, I wanted to cover how will it change my day-to-day. So I'm going to run a little fast to make sure that we have time for the rest of the team. But if you want to come back and go deeper, we can, if you have time left over during the Q&A. And for this, I wanted to give you 8 quick examples of how video AI is changing the day-to-day for LP and other divisions. Let's start with shelf stock levels, right? So shrink is a big problem, stealing, and so on. So first of all, you need to know what's on the shelves. So traditionally, you have staff rounds once a day, once a week, inventory once a month. But of course, it's a long delay. With AI, what you can do is you can have robots. So there's a company called Attendees Robotics. They have these robots running around trying to capture video shelves, or Brain Corpus, these robots as well. Or you can capture video to figure out what's going on in the shelves. Or you can have shelf cams, right? So Dragonfruit has these tiny shelf cams you put on the shelves, and they are capturing the images of the product. So now you have real-time stock analysis. Or self-checkout, where you have SEO machines that you're deploying, but the problem is that the computer experience is sometimes dodgy, and you have loss and fraud. And so with AI, you can either use a never seen like a solution where you're basically stopping transactions, or something like a heavyweight solution, or you can do lighter weight solutions where you're basically you don't have to replace your self-checkout machines, right? So using more modern AI than what we have seen before, you can actually do at a low cost, like $1,000 a year kind of interpretation of transactions and be able to detect fraud. So here the person has, red bell peppers, yellow bell peppers, but they're coding it as bananas. Classic self-checkout. You can also use it to understand sales data. Let's say you're introducing a new product. You want to understand if it's actually taking off. Usually we have to wait for a quarter to get sales data. But with the cameras that LP teams have installed, that's amazing, because now what you can see is like, hey, like I have this Tropicana rebrand happening. The sales will take 3 months for me to figure out, but I can see how many people are walking by the shelves, how many people are engaging with the product. And so you can get early data using computer vision on how well your product changes, or end cap changes, or retail media is changing. even something as simple as traffic counting, right? Like we all have retail locations with these little door counters, and they're kind of inaccurate, right? So like my classic example of that is this, where there is a staff member which is interested in something that's happening outside, ducks out for literally a couple of seconds to see what's going on, comes back. Every door counter will count this as one exit, one entrance. But the LP team has these cameras that are pointed right at that entrance. And so instead of the marketing and merchandising team spending thousands and thousands of dollars a year on inaccurate data, they could just use this video, the LP video, to get more accurate analysis. Similarly, departmental performances, right? Like every single store, I went to Philadelphia the other day at the Rite Aid store, like whole Rite Aid store that is showing zonal analysis, right? But you don't actually need that, because using, again, the LP cameras, you can get full visibility into the entire storefront and do really fine-grained analysis. And you can use GPT as your junior analyst. So instead of having someone fly into a prototype store, you can actually get this data all the time, because the LP cameras, unlike the traffic counters that have limited visibility, cover the whole space. So this is actually an example. Every color here is an LP camera. We didn't change anything. This is actual coverage. And none of you are surprised that they had perfect coverage of the entire space, because that's the job. Like, you make sure, if you're going to put security cameras, you cannot have blind spots, right? And so because you don't have any blind spots, the marketing and merchandising team can benefit from AI. Split trips and falls. The CFOs love this one because it reduces insurance costs when you're able to show that we have an AI that is taking care of, again, same LPI cameras, use those cameras and be able to detect that there's a slip, trip, and fall, or there's a liquid spill, of course, corresponding to it. Which, of course, brings us to liquid spill detection. People are deploying like literally tens of thousands of dollars per store or more on like robots walking around. Why? I mean, you don't need that. You can just use existing cameras. And, in this example, there's a spill. Of course, the customers left and didn't inform the store. And now you can actually detect it in real time. And then finally, the illustration of how vision can change these things is intrusion alarms, right? So traditionally you have contact or infrared sensors, and now you can have 40 sensors. Alarms can go ignored or unmonitored. Now, because you have pixel detection, instead of pixel detection, you have AI. You can reduce false alarms, and you can stick a sticker in front of the storefront. Have people use this instead of patch panels as well. So we think you're going to see a lot of that this year. This is it. This is my fast run through on number one, what all of these terms mean, and number two, what use cases AI can bring to LP and AP. And I'll stop there.
Beautiful. Well, I mean, I'll tell you, I think we're all a little bit smarter after that one. I know I certainly learned, quite a bit. I love the way you actually even kept it black and white. Nice, simple, clear. I loved your analogies. They were fantastic. We've got a lot of applause and little hearts going up on the side here too, which is always good to see. Super, super helpful. And it's funny, when we met at the Loss Prevention Foundation meeting last year, I know that you had stood up, in front of everyone and said, hey, if you don't know about AI, you better get on it, and if you're not using it, you better get on it, because your competitors are using it, other companies are using it, and it's going to just continue to accelerate, light years ahead. So hopefully, for folks even like myself who maybe didn't quite know all that much about it, you just gave us all a really good education there. So thank you very much for that. Appreciate it. If you guys have questions, go ahead and drop it in the Q&A. We're gonna keep going. We're gonna actually have a little bit of a panel discussion at the end once all the presentations are done, and we will be covering off on some of those questions as we wrap up and put everybody together, so we can get the input of all the speakers at the same time. So if you have questions, please do drop them in the Q&A on the bottom of your screen, and we'll use those for the panel discussion. Quick note on Salient. Salient addresses the unique challenges of the retail industry's video management systems with customizable solutions that integrate seamlessly with existing systems. Complete View provides comprehensive asset protection and loss prevention, offering real-time monitoring, historical data analysis, and operational improvements. Salient Cloud Services extends these capabilities securely across locations, facilitating convenient mobile access without compromising data integrity. The flexible architecture supports integration with third-party technologies and secure sharing with vendors, empowering businesses with comprehensive operational insights and protection. Reach out to Salient for a one-on-one demo today. You can email Grant Cowan at grant.cowan@salientsys.com or give them a call at 512-617-4800. All right, let's go up next. Jack, we'll keep this rolling along here.
Okay,
Let's
very
introduce
good.
Michelle.
That was outstanding, by the way. Next up, we have Dr. Vishal Patel, who's the Chief Technology Officer for Appriss Retail. Welcome, Vishal.
Thank you, Jack. All right.
Can you start by just giving us a little bit of your background and what you're all about?
Absolutely. Let me go back to my slides. So first of all, hello, everybody. Very excited to be here. I hope you're only seeing my slides right now, correct?
Yes, we see your
We've got
slides.
Well, we can see you in the little video window on the side. So there's some good fireworks going off behind you
And
right now.
fireworks if I put my 2 thumbs up, thanks to my map. All right. So with that, let's get started. My name is Vishal Patel. I am the CTO for Appriss Retail. We'll talk about what we do and how we use AI, ML, and some of the other cool new technology out there. I also teach AI deep learning, which thanks to Amit's explanation, now you know it's about deep neural networks at University of Louisville. So I teach as part of the Masters in Business Analytics program there as well. So who's Appriss Retail, right? So we're a bottom line impact company, right? We obviously, if you're in the loss prevention space, you probably have heard of us in some way, shape, or form, or if you haven't, our goal really is to do profit protection, margin recovery, and just minimizing loss. And the way we do that is by applying AI, ML to data, right? So unlike the previous session where we're talking about more about video data, here we're going to be looking at more of that transactional data and how these advanced algorithms can be applied to that. Our mission, again, is to every person, every channel, whether it's online, in-store, and every experience, we want to try and analyze it and make it more profitable and identify fraud and abuse and risk in that particular transaction. I won't go into any details, but we've done this for 20 years now for lots of major retail brands globally. So with that, let's jump and talk. I'll just continue the discussion on neural networks, right? So to continue to set the stage of why these neural networks have been so exciting, I thought I'm going to give you an introduction of what these are. I'm going to try and give you a live demo of actually building a neural network. So by the end of this session, we can all claim to have built a ML model ourselves. Can I get somebody to confirm that you see my browser now?
Yes, we've got it.
Perfect. All right. So what is a neural network, right? So we're going to try and build something very, very simple here. So here is some data that I've got. I've got some blue dots here, and I've got some orange dots here, right? So my input, based on some value of the X and some value of the Y, I can tell you if the dot is blue or orange, right? And to do this, again, I've got my X1, which might be this axis, X2, which is this axis, and I'm trying to build a model. So here is these different neurons in what you would call a neural network. You could have multiple layers, right? Again, you can read more about neural networks, but really when you start building this model, essentially, and what I'm going to do is I'll just hit play here, and you'll see that it learned that pattern, right? So very quickly it went from not knowing anything, and actually let's start out from the beginning and go step by step. The model initially knows nothing, right? That's what an AI model starts out. It starts out with complete random weights. And as I click through it, it's going to slowly start to go, okay, I think I see this pattern. Maybe dots here are in the blue region, dots here are in the orange region. I keep going, and each iteration, it's learning a little bit more information, and it's trying to figure out what is that inherent relationship, or what is the function that very clearly defines that input and output, right? And over time, it's going to keep going when it finally says, okay, I have learned this, right? I've learned this function, and I know that if a dot appears in that middle section, it's going to be blue. Everything else is going to be orange, right? That's what the model has really learned. We can look at more complex examples, right? Here is some more complex data where, again, the model very quickly learned that, okay, things in this section are orange, things in this section are blue. But this essential pattern, right, can get arbitrarily more complex. Like, let's look at this pattern. Now, you might think, okay, I mean, as a human being, I can see this, and my eye already knows that these are two spirals, one is orange, one is blue. I can ask anybody if a data point appears right underneath this orange section here, what color is it going to be? And you'll say, yeah, it's likely orange, right? Because I see that spiral going in that direction. But a data set like this is actually extremely hard, even for a neural network, right? And this is where you can build more complex neural networks, right? Let's go add a few neurons. Let's add more weights to this, right? And you'll see that it'll start to, with a lot more complexity, start to be able to pick up that information, but still it's not quite perfect, right? And this is what we mean by you've got to train your models. You've got to learn how do they behave, right? What are areas where the model is very good? What are its weak spots, right? Because even in this example, while it's a very good approximation of that function, it's not perfect, right? Because we know that this whole blue section at the bottom is not actually going to be blue. There is a nice band of orange if we just let that spiral continue out. So anyway, hopefully that was a fun primer to neural networks, right, and how they work. But what fuels these types of changes, right, in the AI ML space? One, it's oftentimes more compute or more clever ways of being able to build these complex models, right? Neural networks have been around for 20, 30 plus years now, but thanks to all of the new innovations in computation and gaming, frankly, we now have the compute to be able to do these types of operations very, very quickly. It gets fueled with more data, right? The more data sets that we have, transaction data, right? Image, video data, whether it's data around RFID tags, right? It could be inventory data. All of these different sources can essentially help you continue to build out that story. And occasionally it's new algorithms, right? Things like generative AI that didn't exist up until perhaps a decade ago when somebody came out with the first set of generative models, or a year ago when somebody came out with these really clever language models. It's these types of new algorithms that can help fuel change in the AI space over time. And finally, it's lots of experiments, right? People are doing lots and lots of new experiments to try and see what works and what doesn't work. What I showed you a couple of minutes ago was an example of that experimentation, right? You could have spent time there, which, by the way, if anybody wants to have fun with that in your browser, feel free to just Google TensorFlow Playground, and you'll get to that, and you can build your own little neural networks to try and mimic that data. The space of the AI and ML, right, and every industry has gone through this in many ways. A lot of what we do today, right, started out with simple rules, right? Back in the early 2000s, people had rules, and this is even the same for your credit card authorization, right? Back in the day, you had to put a travel notification every time you traveled. Now you don't have to do that because there are intelligent models that detect transaction behaviors, right? But in the early 2000s, there were a lot of rule-based models. Then came the age of statistical models, or your traditional stats models, which have now gone on to do more newer generation, more aggressive machine learning algorithms, whether it's neural networks, gradient boosting algorithms, decision trees, random forests, right? All those types of models. Ultimately, where we are going, right, into the future and today is not only can we detect, right, something is fraudulent or abusive, but we can actually now get down to very specific topic level models where we could say, hey, this consumer, the activity that the consumer is doing is actually a pattern of wardrobing, right? Or this type of transactions that we're seeing is actually an example of an ORC group that is working together, hitting multiple stores and exhibiting a type of behavior. Or this set of transactions are really relevant to tender laundering, where you're seeing that a lot of that either transactions are happening and then the tender, right, is either being converted into store credits and gift cards, and it's eventually leaving your store. So over time, we've been able to get to these very, very specific types of behaviors, again, because we have more compute, more data, and all of these new exciting algorithms that we can apply to these types of problems. But we can apply that to a variety of use cases, right? And today we have these two real products in two different buckets, right? One where we do these real-time authorization, which where you have a model that's actually making a decision whether a transaction should occur or not, right? Should we allow this order to happen? Should this claim for an item not received be approved or declined? Should this return that somebody is trying to make a return in the store or online, should that be approved or not? And again, in all of these, you're taking in that data about the transaction, you're taking in all of the history about that individual, and then you have these models that are trying to give you a accurate recommendation of whether it should be approved or declined. Similarly, on the post-transaction side, again, we have different exception-based reporting solutions there. But again, all of that data is helping loss prevention analysts just be able to identify these patterns and take quick actions on these patterns, right? With that, I want to shift gears a little bit and talk about generative AI, right? Generative AI essentially is using that same neural networks that we were looking at, but there the goal is slightly different, like we discussed earlier, right? That you're trying to use that pattern to create new data or create new structure, sometimes new original content. How large are these large language models? Quite large, right? Some of these models have, like the GPT-4, is estimated to have about 1.4 trillion numbers in it. So think about the magnitude of that, right? Just to predict what is the next word, right, in a given sentence, right? I'll just use the same example from earlier. What is the capital of Egypt? The capital of Egypt is Cairo, right? Each time it was predicting the next word, it had to multiply, right, 1.4 trillion numbers based on that input to come out with some type of an output that says, yep, this is the most likely next word. But as you can see, when you do that, you can come up with some really, really interesting, exciting use cases, right? So again, your AI model is basically taking some type of an input in the generative AI use cases. We're sending that through the AI model, and you're coming out with some output, right? It could be things like, write me a blog post on a given topic. Great. It takes that input and it tries to generate an entire blog post, right? Or write me a resume, or even music and video, right? Create a new song in the style of Dash, right? Whoever your favorite artist is. And it tries to generate completely new content that follows the same pattern and the same underlying properties of the original content fed into it, right? This can be used to write code, right? I can tell you, compared to 3 years ago to today, almost all of my team uses some type of a code writing co-pilot in their process, right? Because it's integrated right into their IDEs, and as they're coding, that co-pilot and assistant is just simply sitting there, giving you helpful recommendations, right? That this is maybe you meant this, but this is what you actually typed, or here is something that I can now detect even before you've done writing the code. It has found a bug in your code and in your logic, right? And that's again an area where AI models are going to continue to be these nice assistants sitting there helping you boost your productivity, right? Or you can create some fun things like create a picture of a cat wearing a baseball hat sitting at the beach, and it will generate an entire picture for you. More recently, we have probably in the last 6 months to 1 year, we've been doing a lot of research on applying these types of generative models. Again, specifically for 2 use cases here that I'll cover for loss prevention, right? The first one is what we call case linking or ORC matching, right? You have all of these cases where you have a robbery, a shoplifting, right? You have petty theft, you have chargeback related issues. All of these things are recorded in your case management solution. Well, could a large language model, right, your chat GPTs of the world, could they help you auto-analyze all of those free-form text descriptions and tell you, hey, actually, this is the same underlying ORC group that we see is targeting these 8 stores in this geographic location, right? Again, helping the analyst or helping the investigator perform that investigation faster, right? And a second area where we're trying to apply this same capability is how would you take a GPT model and essentially ask questions or ask reports in a more natural language way, right? Instead of you having to configure these long reports and drag drop things, identify filters, could we, in a more human understandable format, ask for that same data or the same questions? So yeah, AI models to identify similar cases and help quickly summarize, right? And let me show you an example of that, what that could look like, right? Again, this is all out into the future type of capabilities, but here are 5 cases, and here is ChatGPT, right, or a GPT model underneath, telling you that, hey, based on all the cases in this group, we found 2 suspects named Bonnie and Clyde, and they seem to be stealing Yeti coolers always between the time of 2 p.m. and 4 p.m. And the total case value here is about $18,000, right? So instead of you having to manually go through all of that, it tried to summarize that and give you a easy to understand description. Another area of that, as I mentioned, would be these types of search capabilities, right? So instead of you having to configure a report, could an analyst or an investigator simply say, hey, find me cash transactions that happened over $300 in the last week from store 231, right? Instead of you having to manually create these types of reports. Again, we're using a large language model or generative AI model to take this and convert that into a set of queries that we can now ask the data back, right? And again, as the number of data assets in your organization increases, you're able to use these things to very quickly get that information back and start to take action, right? AI demos are obviously very easy, but AI products are extremely difficult, right? You'll see that there's obviously an explosion of every company out there talking about how they're using AI and ML, but actually applying them correctly, applying them responsibly is a whole other challenge. And there's a lot of considerations now to think about, even around ethics, bias, moderation, accuracy, right? Around some of these models. And I know we have a session upcoming specifically to talk about some of these things, but what you will see even within your own organizations is there's going to be a lot more scrutiny around the responsible use and application of AI into the different workflows that you might have either within your own organizations or through solution providers that you're now trying to bring it into your organization. So with that, what does the future of loss prevention look like? Right? And this is going to be my last slide to summarize some of these things. Productivity enhancement, all of these different co-pilots, whether it's a co-pilot trying to help you write code, whether it's a co-pilot trying to solve the problem of reading extremely long email chains and trying to help you summarize what you missed on a very long chat channel, or whether it's co-pilots that are trying to help you make sense of your data faster, right? Make sense of, or connect and complete your investigations faster. There's going to be co-pilots that will continue to be those productivity enhancers. There's going to be a lot more focus on real-time detection, mitigation of fraud and abuse, right? As we can build models that can accurately detect some of these things, more and more of those are going to be detected and stopped in real time, right? We're going to continue to help analysts write more complex queries faster, right? You don't have to be an expert at coding now to be able to do some of these more advanced analytics, thanks to generative AI. we're going to see that a lot of the end users are going to be able to consume that data faster, right? Loss prevention professionals who are especially on the field, right? Those field users will be able to, again, take that data very quickly, summarize that data instead of having to look through long reports, multiple emails. They'll just know the exact insights that really matter as perhaps they're doing a store visit, right? And then we're going to enable new use cases, right? And all of these new areas where currently we're not able to take action. And last but not the least, this is going to have an overall impact on just risk across the board, right? Just as we are building new AI ML mechanisms to identify and deter fraud, so are the fraudsters, right? There are completely fake individuals out there. The next time your customer service rep is talking to somebody, are they actually talking to a human being, or is that just an AI system behind the scene just making calls and putting in fraudulent cases of refund and fraud, right? The next time you're chatting with somebody, just like you think you're chatting to a bot, there might be bots chatting with each other, right? Because just like we're applying new tools to mitigate this, there are fraudsters applying the same type of tools to also circumvent some of these controls that are put in place. But obviously, this is also going to have a lot of good things that we can get out of, right? I was seeing this crazy but very exciting use case where somebody was trying to build out a e-commerce portal where you should be able to just upload a few pictures of yourself, and as you browse through the website, instead of showing you just model pictures of a given t-shirt or a given dress, it substitutes it with generated AI pictures of you and shows you what you might look like in that t-shirt or in that dress, and you just are now going to, again, continue to persuade you to buy it. And you don't even have to upload things, right? You can just connect it to your Instagram or your Facebook, and it brings in that information. So there's a lot of those types of, again, new out there wild use cases that people are going to continue to explore. So hopefully you found that useful. And with that, I will pass it back to Kevin.
Vishal, thank you so much. That was incredible. And it's funny, I listen and I watch and I see how these queries are made now compared to the way that I had to do them back, 25, 30 years ago, when you would write, 6 or 7 different queries up against a mainframe database. You would, hope that you got the right data back, and then you'd go through all the process and not. And now I could just, at the end of the day, what I was looking for was a negative balance on any credit card that was used in the past 6 months, with the total, give me the total of all transactions over the last 6 months on any card that has a negative balance. I want to see those accounts.
Yeah.
And you had to write, it took a week
all of these
to find
things.
that data. And now you could literally type that sentence and hit go, and there you go. It's incredible. You mentioned the people who may not be real on the other end too. Microsoft's VASA, the VASA, I think it's VASA 1 or something. If folks have not tuned in to check that out, they literally upload a picture of somebody, and then that picture is talking. It's got a voice. It's got, and it looks pretty darn real.
Very real. Yeah.
It's just amazing. So that real versus fake is definitely real and not fake. So thank you for that. Appreciate it. Again, questions for Vishal, please put them in the Q&A so we can get those compiled for the next section here. I'm going to go real quick into if there are questions, and then let's move on to Jack introducing our last speakers for today. But before we do that, we just learned a little bit about Appriss, but I'll tell you that the information that I'm supposed to read, Vishal says, wherever your customer engages with you, Appriss Retail protects the transaction against fraud and abuse. Appriss Retail combats return, claim, and transaction fraud, both online and in-store, protecting your profits while safeguarding your relationship with loyal customers. And you can learn more, not only from Vishal today, but at apprissretail.com. And we did hear already from Amit, but Dragonfruit AI partners with leading global brands and retailers to harness the power of video data through a unique platform that combines the efficiency of the Apple M1 chip with the creativity of generative AI, which now we all know a little bit more about and we understand. Dragonfruit's comprehensive range of applications encompass everything from sophisticated security alerts to detailed retail analytics. This diverse portfolio caters to a broad spectrum of market needs and enables Dragonfruit to offer tailored, cutting-edge solutions to a wide array of clients, from retail giants to security-focused enterprises. Learn more at dragonfruit.ai. All right, and now we're running up to our last set of speakers here. I'll tell you, we did a little research and we found some folks that have some great experience in all this privacy, biometric, legal. I'm not going to call it mumbo jumbo, but it's all that stuff that we may not understand yet. And there's certainly a lot of people out there who don't understand what the privacy concerns really are. And which, going back to real and fake, which ones are myths and which ones are realities. So hopefully we'll get Nicola and Justin to expand on that for us. Jack, you want to introduce our next speakers?
Yeah, absolutely. There's an awful lot there we talked about so far today that's really exciting, but as our loss prevention audience will tell us, there's also a lot of questions that they're going to have as we start to dive into this. And to help us through some of that, we have Nicola Minaldo and Justin Podesta to help us work through some of those issues. Thank both of you for being here today.
Thank you, Jack. Thanks, Kevin. And thanks, Amit and Vishal. You will certainly be a hard act to follow. I'm Nicola Minaldo. I'm a partner at Perkins Coie, which is a law firm that specializes in technology. And my practice for the last several years has really centered on AI and biometrics. And biometrics, as we'll describe a little bit more in a moment, is all about the data about people and the sort of unique physiological and behavioral characteristics about people. And as we'll discuss, there's a lot of laws cropping up around the country around how you handle that data. So before we dive into the Q&A, which I know you want to save some time for, Justin and I are just going to briefly set the table on what the legal issues are. We are not your lawyers, so this is not legal advice, but hopefully this will give you a little bit of an overview of which corners you want to look around, where you might want to do some additional due diligence, and just where we see things heading. So Justin, do you want to give a brief introduction of yourself?
Sure. I'm Justin Batesta. I do a lot of the same work that Nicola does here at Perkins Coie. And just to expand on that a little bit, our practice really encompasses all stages of kind of companies considering this AI lifecycle. So companies developing AI products, companies considering deploying AI products and evaluating vendors, things like that. And so we deal with consumer-facing applications, employee-facing applications, as well as sort of supply chain and business-to-business applications.
That's right. So these are the three, this is the outline for our presentation today. Justin will start just laying the groundwork for why you might care about legal issues in this space when everything else is so exciting. I'll then just give you a really high level view of the legal framework that applies now and that's emerging for dealing with biometric data. And then we'll leave you with some takeaways. So I'll pass the baton to Justin to get us started.
Yeah, thanks, Nicola. So as a starting point, and I think we heard some of this in the prior presentations, but as a starting point, we wanted to focus in on the opportunities here, right? The opportunities for loss prevention professionals to be deploying AI technologies. And as you can see in that top bullet, this is courtesy of our friends over at APRIS. The shrinkage, the total shrinkage in the retail industry for 2022 is over $112 billion. And so certainly there's opportunities to mitigate that loss by using AI technologies. And these are three of the areas that we really see AI-powered solutions being deployed. The first one is arguably the biggest, enhanced security and surveillance, or at least that's maybe the one that comes across Nicola and mine's desk often. And what we're talking about here is technologies that are using facial recognition, voice recognition to identify consumers, maybe track them through a store. Recently, Nicola and I have seen technologies taking maybe a more anonymous approach to this surveillance and tracking the general outline of a person's body as they move through the store, so that you're not focusing necessarily on the face and some of that sensitive data we'll talk about today. So that's certainly a big use case. The second is sort of risk analytics for customers, employees, and vendors, predicting fraud, things that Vishal talked about in his presentation. And the last is AI-powered security robots. We're seeing those being deployed in stores throughout the supply chain. And as those AI-powered robots are being deployed, they're obviously ingesting data in new ways about consumers. And so that's the common theme throughout all of these that we'll touch on today, is sort of as companies are deploying these AI solutions, they're ingesting new types of data and they're potentially exposing themselves to new risk. And so as on the one hand, we have these opportunities that we're discussing, but we also have these really big risks that can come along with these technologies to the extent, people aren't forward thinking in how they're deploying them and addressing some of the legal risks. So I'll briefly go through these. So recently, Target was sued by a woman under an Illinois biometric privacy statute that we'll double click on here in a minute. And these are just allegations. It hasn't been proven or anything like that, but it's a lawsuit that alleges that Target was collecting facial recognition data from customers that entered and exited their stores, was tracking these people through the stores, and was trying to predict their behavior using that data. And so the thrust of the allegations there that Target wasn't obtaining appropriate consent, wasn't providing sufficient notice to customers of this use. The second box that you can see on your screen, this is a recent regulatory enforcement action against Rite Aid for deploying similar technologies, and we'll zoom in on this a little bit more later in the presentation. But what I want to focus on here is that the regulatory environment for these technologies is really heating up. The FTC and others are really getting involved and closely scrutinizing companies' use of these technologies. And so that's certainly something to be aware of. And the last box here you see is a somewhat recent settlement by Facebook. It was also in a case under that Illinois law I mentioned earlier. And it was for $650 million to settle a class action lawsuit involving the platform's facial recognition features as to, sort of photo tagging. And so the upshot here is that the risk is palpable, and the risk of significant financial exposure for failing to really think through these technologies and comply with the laws can be significant.
So what is your legal framework? We, as Justin mentioned, we help clients all the time develop and use these technologies, and the message is certainly not, don't use them. I think in most cases, there is mitigation that can be put in place to reduce your risks and comply with sort of this emerging and ever evolving regulatory environment. And what do I mean by that? So in the United States, privacy is regulated through a patchwork of regulation. There is no federal privacy law that we can all look to for guidance. And that's part of why this is so sort of complex and risky. There is pending federal legislation that was just introduced recently that could change a lot of things, but that's not enacted yet. And any of you who follow this issue know that federal privacy bills have come and gone many times before. So we're not holding our breath, but this one looks like it is promising. The Federal Trade Commission regulates unfair and deceptive practices. And it has signaled in recent years that is particularly focused on biometrics. And again, we'll talk about that Rite Aid settlement in a moment. But that's an important part of this framework. Then at the state level, there's 3 types of laws that regulate biometric privacy. Some states like Illinois, Texas, and Washington have laws specific to biometric privacy. Other states have laws about privacy generally, and that's like the California Consumer Privacy Act and the 12 or 13 or 14 other states that have recently enacted these sort of broad-ranging privacy laws. Those laws also regulate biometric data along with other data. And then finally, there's a new crop of consumer health data laws. You're not going to really see that in loss prevention, except maybe on the employee side. But the flag here is those can be sort of unintuitively broad and cover things that you might not think of as health data. And they do cover biometrics in that context too. Finally, in the US, there's local and city laws. So in Portland, Oregon, for example, they've banned facial recognition with some exceptions. And in New York City, there are some signage requirements about using about collecting biometrics in retail and food and other types of establishments. So, bottom line, it's tricky. It depends on where you're deployed, where you're using technology. And it's why we sort of flag if you have a people tracking, people observing, loss prevention technology you're considering or using, it's worth running that by legal and making sure that you are compliant with all these different laws. And we'll focus on US law today to keep things simple, but the US is not the only country in the biometric privacy game. And so we flag that here as well. So what are biometrics? Really, the definition varies widely, but when we talk about biometrics and what we're talking about in this presentation is really any information, including like automatic measurements of a person's physiological, biological, or behavioral characteristics. And so things like face scans or face embeddings or face hashes, those are generally considered biometrics. Fingerprints, eye scans like retina or iris scans, voice prints, things like photos and videos standing alone typically will not trigger biometric privacy restrictions, with some exceptions. But people have been taking photos and videos through CCTV in retail for years and years and years. So really the heightened risk that we're trying to flag today is where you take that photo and video and you analyze it in a way that's specific to people. And that's where you can get into a zone that some might claim involves biometrics. So Justin's going to talk about now, like, what do all these laws say? Like, what are the basics of how you protect biometrics?
Yeah, thanks, Nicola. And one thing I want to focus on here is that the laws that we're talking about, for the most part, aren't prohibiting the use of biometric technology. What we're really talking about is regulating the technology and steps that companies need to take in deploying them. And so these are sort of the main requirements that we see. Obviously, as Nicola said, there's a lot of different laws, the requirements vary, but these four are kind of recurring themes across these laws. And so that first one, notice and consent, that's a big one in several jurisdictions. And really what we're focusing on here is making sure that the people who are appearing in images that are being analyzed, whose biometric data might be collected, that those people understand that that's going on, and have an opportunity to opt out or to avoid the collection, depending on the law in question. There's also limits on sharing the data, and at times these laws can prevent sharing across affiliates, which sometimes can be something that unintentionally trips people up. People don't expect that, and so that's something to be mindful of as you're ingesting and working with this data. The third one are retention and deletion requirements. So a lot of these laws place limits on how long companies can retain biometric data. And this is actually a really interesting one in the context of AI, because what we see at times is a competition between compliance folks who want to comply with these retention and deletion requirements and folks developing these AI technologies who want to retain the data for training purposes. And so that's usually a negotiation within a business. Sometimes it's a negotiation with the vendor who's developing these technologies, but it's certainly an issue to be mindful of. And the last one is physical and digital security requirements. So given the sensitivity of certain types of biometric data, the fact that they're unique to a consumer, these laws require you to protect that data and to make sure that there's not instances of unauthorized access. And that includes things like, securing the databases that these are stored in, making sure only certain employees have access to the data, physical security requirements, so making sure that the data centers are located in a physically secure place. So that's a brief overview of the requirements. And this next slide, sort of going back to our discussion on the BIPA lawsuits, the Illinois biometric privacy lawsuits, I think this slide's fascinating. This slide represents the filings, the case filings that have been initiated under BIPA since the end of 2015. And as you can see, they really started to take off in 2017, and they're growing steadily ever since. I think since 2017, if you do the math, we're averaging about one BIPA complaint a day. And so this is a really, really active area of litigation. And part of the reason for that is the damages that consumers can collect for violations are really, really high. They can be up to $5,000, not just per consumer, but per scan, per time that the person's biometrics are collected. So again, it just poses a serious risk for failing to comply with these laws.
So Justin just double clicked on the Illinois law, which is really the hotspot and the place to focus efforts when you're dealing with these technologies because of that litigation risk. And now I'm just going to zoom in a little bit on the Federal Trade Commission. And because for many years, Justin and I, neither of us are in Illinois, by the way, but a lot of our practice has been focused on this Illinois law. That's shifting a little bit. The Federal Trade Commission is in the biometrics game. And as I mentioned, they have indicated that biometrics are a priority. And last year, they issued a state policy statement on biometrics, sort of putting forth their view on this sensitive type of data. And the basics here are, these two points summarize their main cautions. One is when you're making a statement about how you're using biometrics, it needs to be complete. And you can't say you're using biometrics for one purpose and then also use it for something else that hasn't been disclosed. And the Federal Trade Commission will view that as a violation of federal law. The second is that unfairness, or a different type of violation of the law they enforce, could result if biometric collection isn't clearly and conspicuously disclosed, and especially when it is required to access essential goods and services. So what does that mean? It means that the FTC would like to have a standard where if biometric data is being collected, that notice is provided to consumers. And the FTC is suggesting that it may not be appropriate to collect biometric information if a consumer needs to agree to provide that to access a good or service. Now, Justin and I know that, the technologies that involve biometrics are fairly prevalent in the loss prevention space and have been for many years. So in some ways, I think this standard is a bit aspirational. I don't think the law is quite there yet that in every state you need to provide notice and or get consent, and you can't use biometrics to provide your services. But I do think it signals this space is changing quickly, and it's worth being very alert to what's going on here, paying attention to the Federal Trade Commission, because this standard could develop quickly to a nationwide standard where you do need to think very carefully about notices, not just in Illinois, and consents, not just in Illinois, but everywhere. Moving on to the next slide, this again is an example of the Federal Trade Commission caring about this issue. As Justin mentioned earlier, they agreed to a settlement essentially with Rite Aid in connection with Rite Aid's use of facial recognition. And it really boils down to the allegations from the Federal Trade Commission was that Rite Aid hadn't engaged in the sufficient due diligence and training to avoid discriminatory effects of their facial recognition system. There's more than that, but I think that was the thrust of the complaint. And as a result, Rite Aid is prohibited from using its facial recognition system for a period of years. It also was required to disgorge or get rid of its algorithms that it had trained with facial recognition data. So a pretty strong remedy that the Federal Trade Commission demanded in that instance, and really one of its kind. This is the first action we have seen against a retailer for using in-store technology like this. So I do want to leave some time for questions, and we've only got 2 slides, so I'll let Justin take us around the bases.
Sure, I'll keep this quick. We focus mostly on biometric AI up until this point, and I really want to zoom out a little bit and say, the coming landscape is likely going to include regulations much broader than that. And 2 things that I wanted to highlight on that front are California has regulations, and there's a proposed federal privacy law. And both of these seemingly will regulate a broad swath of technologies and AI decision-making technologies where consumer data is being used to make decisions and to make predictions about consumers. And so at the bottom of the screen, you can see some requirements that these laws are going to include, and assessing the technology, evaluating AI for accuracy and bias, like Nicola talked about, and again, notice and opt-out rights, descriptions to consumers about what these technologies are doing. And so here, we wanted to leave you with some concrete takeaways. We've kind of gone through the law and some of the risks, but this list really represents some of the best practices in our view in this space. The first is obviously understanding if you're collecting biometric data, assessing, what your data looks like, how identifiable it is, where it's being collected from, considering model training issues. Sometimes this data is being used to train things, and there's unique issues with that around consumer consents and privacy issues. And again, like addressing biometric privacy risks before deployment. I want to zoom in on this one because this is important, and this is something that Nicola and I sometimes are called in after the fact, after a company's deployed these technologies to try and clean things up. And it's a lot more difficult to implement those compliance strategies further down the line. But if we're able to get in early and help a company analyze risk and deploy these mitigating strategies around notice and consent and retention and deletion and things like that, it really helps protect against the risk down the line. Assessing vendor compliance, if you're using a third party for your machine learning solutions, making sure that vendor is a trusted partner and is complying with these laws as well. Implementing consents, we talked about that. And incorporating AI/ML into biometric compliance and existing government structures. That's something that I think is important to think about, is that sometimes we think about AI/ML as this like crazy new technology and it's unlike anything we've seen before. And in some ways that's true, but in other ways, I think corporations can leverage their existing resources and fit those compliance regimes within those existing resources, even as applied to this technology.
Great.
And
Well, oh, sorry. Yeah,
go ahead, Nicole.
that is your slide.
No,
Tell
go
us about our
ahead.
blog.
Yeah, this is our Perkins on Privacy blog. If you're interested in developments in the space and things are moving fast, feel free to give us a follow on there.
Yeah, I think that's great, guys. Thank you so much for the information. I love the takeaways too, and that you went right down the path I was hoping you would go down, and definitely added that nice layer of, okay, now that we know what it is, what should we be worried about from a legal perspective? And as we get into the Q&A, I'm going to actually start with you guys, and maybe you could take a look. Jump forward and look back, right? And what do you think? What are some of the bigger concerns that you're seeing or that you expect to see over the next couple of years when it comes to AI and biometrics, especially in the retail sector?
Yeah, I mean, I think the big takeaway from the last 5 to 10 years that informs what I think the next 5 to 10 years will look like is people want these technologies, they like them, and they're useful. And like so many things in technology, the law is often slow to catch up, and so it can just be a complicated space to operate in because there are a lot of business pressures that will that will cause you to want to like get on the bandwagon, and you'll have to, like, this technology is here to stay. You have to embrace AI/ML or you're going to get left behind, is sort of my perspective. But it's also really important to be really careful from a legal perspective and think broadly about not just the laws that are here, but the ones that are coming, and sort of what's responsible to do, and how you're going to like answer the hard questions when they come to you, because there's a lot of nervousness about this technology too, understandably. And you have to balance the sort of privacy concerns with the other really important policy issues that you're dealing with. And in the loss prevention space, that's safety. It's not just loss of revenue, it's also safety. So it's a balancing, it's complex, And so it's just sort of recognizing that complexity, because the technology is here to stay, will help you, I think, stay on the right path.
Excellent. I'm going to encourage folks to, I know that we've only got, several minutes left here, but if you have questions, please do put them in the Q&A, because Jack and I are going to take those and we're going to farm those out to the panel after the call, since we're going to be a little short on the Q&A time here, to get things answered and then get them sent back out when we send the links, the follow-up links coming out of the session. So, please do put those in the Q&A for us if you have any questions there. Amit, I'm gonna jump to you and ask you, we just heard Nicola say, embrace it or you're gonna get left behind. What's your vision of, I know if I look back 5 years ago from right now, I don't think we really talked much about AI, or it was kind of like this distant future, thing, and it sure snuck up on us awful fast. And it's integrated into so much today. What are we going to look like 5 years from now, 10 years from now, and looking backwards?
Yeah, we will be solving the same problems that we've been trying to solve for 40 years. So, if you think about keeping the shelf stocked, making sure that the people get caught, right? We have some new tools with AI. We have some things where, it was hard to automate eyes. You can automate eyes now because visual content was hard to process cheaply, right? Like, processing a VHS tape of hours and hours of videos to figure out where you have like a person used to be expensive. So a lot of the technological trends about things becoming so cheap that they are now easy to do, everyone's doing it, and now you realize, with like ability to do it at scale, you have issues popping up. So from that perspective, I think 5 years from now, we are probably wrestling with the same kind of things that we are right now. Some of those have been solved by vision because it's actually cheap and efficient to implement. But now we're thinking about like, hey, how do we use like the next generation of LLM to do things? The reason I frame it this way is for when we work with retailers, it's problems backward. So we will still be solving the key problems that we have, and each one of them will be solved a little bit cheaper, a little bit faster, a little bit better by deploying AI.
Vishal, what do you think?
I'll keep it short. I think we're going to continue to, automate the boring things and keep doing more interesting things. And that's where I see AI just, again, helping us do more with the time that we have, right?
Yeah, I think you're right. I do wonder, based on what you had said about, we're going to be fighting some of the same problems and trying to do them. Do you think, though, there'll be some more of that automation? I mean, shelves, not necessarily stocking themselves, right? But don't we think that there's probably some advancements that are going to come pretty quickly to solve some of those problems even faster?
Yeah, I think so. So, I just came back from Mexico, working with some of the retailers that are deploying vision-based solutions to be able to do stock out management, right? And the same technology they're also interested in using retail media off of, right? So all of the stuff that is happening in retail media, where people want real-time data on what's happening with Store 64, how many people are walking by my ad, these things will be possible for the first time ever, because it's possible to use the cameras and do the analysis on it. So for sure, I don't want to say that there's nothing new that it's going to bring in. It's just that the key problems, increased revenue, decreased shrink, will be the categories that we are looking at. It's just that doesn't change. Things get slightly better with technology. It's important because, all of the vendors, including ourselves, we're talking about cool tech. Who the heck cares, right? It's not solving your bottom line. So working backwards from the KPIs is, I think, what we'll continue to do. Some of those KPIs will be like, okay, done with that. Now let's look at newer KPIs to optimize.
Excellent. Jack, anything to add?
Yeah, I have one question here. Basically, I think it applies to everybody. If obviously things are changing pretty quickly, okay, but what are some of the factors that the audience, we have a lot of decision makers here that are watching, what are some of the things that they should be looking for when they're choosing a product or a solution provider? that would separate good from bad when we're looking at these different tools?
I'll give mine, and Vishal, you can give yours. Four things that we say that leaders should look at. Number one, use your existing camera infrastructure, because LP has spent the last 10 years deploying like literally tens of thousands of cameras. Like, don't buy new cameras. There is no AI camera that's worth it, right? Like, so use your existing camera infrastructure. Second, remember your bandwidth. Any AI that you're trying to do on the cloud, if you're trying to send video or even a lot of textual data to the cloud, remember that your stores don't have enough bandwidth. So that's point number two that we say. Number three, there's cheaper hardware available. So if someone says, oh, you need like $10,000 of GPU hardware, that's not true anymore. Like, hardware is basically free at this point. Machine learning, AI is basically free at this point from a hardware perspective. This is very different from 5 years ago, where it's like, oh, I've got to do AI, I've got to get new cameras, we got to get like rack servers in the back room. That is not the case anymore. The world has changed in the last few years. And number four, please don't buy a point solution, because each point solution has, its own hardware, its own bandwidth, its own connection to the camera that is required. So know that your existing cameras are good enough. Know that GPU hardware is no longer required. Low bandwidth, be aware of that, and multi solutions using the same camera stream are preferable. Vishal?
Yeah, I think those make sense. I would say, some things to think about, right? Can data solve the problems that you're trying to solve, right? Because the existing data that you are already collecting, are you able to action on that, right? And can you just solve the problems using that? When selecting a vendor, I always ask people to think about, does the maturity of that, what does the AI ML maturity of that vendor actually look like, right? Have they actually gone through a formalized assessment of their models, right? For AI, ethics, bias, all of those things, because and this is why I actually had that in my slides, right? That AI demos are easy, but AI products are extremely hard to do well. And finally, I would say, I'll echo what Amit said around don't buy a point solution, right? Always think about, is there an overall platform that can solve multiple use cases? Because otherwise you're going to be back at the same problem, knowing you've solved one thing, but now you've left the other 9 things on the table, and now you have to go look for another solution provider to solve the other 9 things.
Nicola and Justin, I saw you nodding along there.
I'll add one short thing, and I'm sure Justin has something. There's so many things I could say, but the one short thing is be wary of legal overpromising. If your vendor says we are fully compliant with all laws all over their website, they don't have a legal team behind them fully vetting their compliance. It's a tricky conversation. It's a tricky area. So I would be wary of those overpromises, and just, one that is willing to go through the question and answer process is one that is going to be more trustworthy. Justin?
Yeah, I think the one that I was vigorously nodding my head to when Vishal was speaking is customers or vendors who have thought through these issues. They often have documentation, and usually they're willing to share some of that documentation around risk, documentation around how explainability for AI models. How is the model working? What are these things doing? And so asking for that documentation sometimes can be a really good way to suss out the overpromisers and the underperformers, to Vishal's point.
Excellent. Well, I want to thank the panel here again. I appreciate that very much. Appreciate your time, appreciate your input, your insight, your expertise, your experience. I think we all learned, quite a bit. I've just taken a quick snapshot of all the questions in the chat, so we will share those, and when we send out the link, we will also get a copy of the questions out to folks as well. So I'll send those to you guys to give us your insight on each one of those when you have a moment, and we'll make sure that we get those out to folks as a follow-up coming out of this session. I want to thank our sponsors, Hanwha Vision, Sensormatic, Salient, Apris, and Dragon Fruit, and we thank you guys for also lending us your experts today, and with Think LP. Again, thank you to LPF. Again, if you are LPQ or LPC certified, please do make sure that you've taken note of today's session and that you register for your 3 CEU credits. There's that QR code. I promise will come later. Anybody who has been just sitting there holding their phone the whole time, I apologize it took so long to get there, but now you can snap that QR code and get registered to Loss Prevention Magazine. For those of you who are in law enforcement or friends with law enforcement, we've got those free scholarships for the ORC, recognizing ORC and responding to retail theft training. I've got a ton of those. We've got a new prosecutor and district attorney version of that coming out. That's releasing around May 6th, I believe it is. We just announced it real last week, so that should be out shortly. And I have scholarships for that as well. So for those attorneys that are on the phone, wink, wink, nod, nod, feel free to share that too, because if you've got folks that deal with organized retail crime cases, I've got some free training for you. And finally, the LP Hall Awards. Make sure you get out and do your nominations for the Investigator of the Year, the Team of the Year, the Leader of the Year, our Community Champion of the Year, the Orca of the Year. There's a whole list of them. Visit lphall.com and get those nominations in today. You've got about 10 days left. And that's it for us. We want to thank you again. Again, thank you, panelists. Thank you, Nicola. Thank you, Justin. Thank you, Vishal. Thank you, Amit. Appreciate all that you guys did in getting ready for today and then pulling today off. So thank you for all of that effort. And on behalf of everybody at Loss Prevention Magazine, just want to tell everybody to please stay safe. And thank you. Jack?
We'll get this recording out as soon as we can, guys. I'll make sure that we put a rush on that so that you can share that with whoever you like. Otherwise, thank you very much for being here with us again today, and have a great week.
Thanks so much, everybody.